Good morning, students. Now we will discuss next chapter, that is D block and F block elements. In class 11 we completed S block elements, that means 1A group, 2A group, and 2 groups in P block elements. In class 12 4 groups completed in P block, that means we completed S block and P block elements. Now we are going to discuss about D block and F block elements. First we have to discuss about D block elements. See, this is total periodic table, you know that very well. These are the left side of the elements called S block elements. These are right side of the element, these called P block. Between S block and P block, these are elements present in middle of the periodic table. These are called D block elements, and the elements which are present at the bottom of the periodic table, these are called F block elements. Now we have to discuss about this one, D block and F block. Before that, first we should know what is D block element. What is the definition? The elements in which differentiating electron enters into D subshell is called D block elements. Differentiating electron means lost electron. If that electron is enter into D subshell, then that element is considered as D block element. See, this D block elements contains 4 series in periodic table. They are 4D series, 5D series, 3D series, 4D series, 5D series, 6D series. What I said? These D block elements contains 4 series in periodic table. They are 3D, 4D, 5D, 6D. That means from atomic number 21 to 30, these are called 3D series. Why? Because in all these elements, the differentiating electron enters into 3D subshell. That is why these are called 3D series. From atomic number deuterium to cadmium, in such cases, the differentiating electron enters into 4D series. That is why these are called 4D shell. That is why these are called 4D series. In this case, differentiating electron enters into 5D. In this case, differentiating electron into 6D series. Next one, D block, that means from here to here. This D block contains how many groups? 10 groups. 4 series and 10 groups. See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 groups. Groups nothing but vertical columns. That means D block contains 10 groups. S block contains 2 groups. P block contains 6 groups. D block contains 10 groups. These are starting from which period? 4th period. This is it. Periods are, horizontal rows are called periods. So from these are starting from 4th period. 4th period contains how many elements? 4th period contains how many elements? 18 elements. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 elements. 5th period also contains 18 elements. But 6th period contains 32 elements. See, after 57, 58 to 71, these are called lanthanides. These are also present in 6th period, but these properties are somehow different compared to D block. That is why these are kept separately. Next, the period is, see here, this is incomplete period. So what is the point here? 4th period contains 18 elements, 5th period also contains 18 elements. That is why these two are long periods. But 6th period contains how many elements? 32 elements. 14 lanthanides, 14 actinides. So total 32 elements. 14 lanthanides only, not actinides. 32 elements. See, these are 18 plus 14, 32. These actinides present in 7th period, not 6th period. So what is the point here? These 6th period contains 32 elements and 7th period is the incomplete period. That is why 6th group is called longest period. 4th and 5th period is called long periods. 6th period is longest period and 7th period is incomplete period. Next one. Here one important point is there, that is all transitional elements are D block elements. All transitional elements are D block elements, but all D block elements are not transitional elements. Why? That is very important point. What I am telling, all transitional elements are D block, but all D block are not transitional elements. Before that, we have to know what is D block and what is transitional element. What is D block element? We discussed already. The elements in which differentiating electron enters into D subshell, that is called D block. Then what about transitional element definition? Listen carefully. The elements in which the valence shell and penultimate shells are incompletely filled are called incompletely filled in elemental state or in any one of the significant oxidation state. That is the definition for transitional elements. I just repeat it once again. Listen carefully. The elements in which valence shell and penultimate shells are incompletely filled in elemental state or in any one of the significant oxidation state is called transitional element. If I discuss example, then you will get clear idea. See, for example, take scandium. Its electronic configuration argon 4s2 3d1. This is the electronic configuration for scandium. See, in this case, differentiating electron enters into D subshell, so that this is D block, no doubt. And is it a transition element or not? This is also transitional. Why? What is the definition? See, this is nucleus, first orbit, second orbit, third orbit. First orbit 1s2, second orbit 2s2, 2p6, third orbit 3s2, 3p6 and 3d1, and the fourth orbit 4s2. See, for scandium, this is the valence shell, that means last shell, and this is penultimate shell. So what is the definition? Valence shell, penultimate shells, both are incompletely filled. Then that is called transitional. See, in this one 4s1, 4p0, 4d0, 4f0, that means those are incompletely filled, those are vacant. In third shell 3d is incompletely filled, so that this scandium satisfies that condition. Which condition? Both valency and penultimate shell. The shell which is before to valence shell, that is called penultimate shell. So in scandium both are incompletely filled, so that it is also transitional element. Next, in case of titanium, what is the atomic number? Electron configuration argon 4s2 3d2. See, here differentiating electron enter into D subshell, so that it is D block. Then whether it is transition or not? Transition, because 4 is completely filled, but 4p, 4d, those are incompletely filled, and 3d also incomplete filled, so that this is also transitional. Like that, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, all are D block as well as transitional. Not only this fourth period, fifth period also, yttrium, zirconium, niobium, molybdenum, technetium, ruthenium, rhodium, all these are also D block as well as transitional. Now here one important point is that take copper. What is the electronic configuration? Argon 4s1 3d10. That means 1s2 2s2 2p6 3s2 3p6 3d10 and 4s1. That means in copper case, valence shell only incompletely filled, but penultimate shell completely filled. Copper is what? Atom, elemental state. That means in elemental state, copper is a D block, no doubt, because differentiating electron D subshell, but it is not transitional in elemental state. But copper exhibit two oxidation state, that is +1 and +2. But in +2 state, the electronic configuration is 4s0 3d9. That means every time +2 means what? We have to remove 2 electrons from outer shell. See, this is the electronic configuration for copper. While removing the electron, first we have to remove electrons from outer shell. So here outer shell contains only 1 electron. Then 4s1 becomes 4s0, and we have to remove one more electron from this one. That electron is to be removed from 3d. So automatically 3d10 becomes 3d9. So this is what electronic configuration for Cu plus 2m. In this electronic configuration, copper acts as transition element, because 3d10 becomes 3d9. That means 3d is incompletely filled. That means penultimate shell is incompletely filled. So what is the point here? Copper acts as transitional element in oxidation state. What is the definition of transition element? The elements which are incompletely filled, the elements in which valence shell and penultimate shells both are incompletely filled in elemental state or in any one of the significant oxidation state. So copper, in case of copper exhibits shows transitional element character in oxidation state, so that this copper atom considered as transition element. It should, if any element having incompletely filled configuration in valence shell and penultimate shell in elemental state or in significant oxidation state, then that element is considered as transition element. Not only copper, this is silver, gold, because all are having similar electronic configuration. That is why these are put in same group. This gold and this silver and gold also having transitional properties in oxidation state. That is why these copper, silver, gold also D block elements as well as transitional elements. So no doubt, from this group to this group, from this group to this group, all are transition elements as well as D block elements, because these elements act as transition elements in oxidation state, so that these elements considered as transition elements. Next, one more important point is that this group is also called typical transitional elements. Typical transitional elements. Why? Because they act as transitional elements in oxidation state, not in elemental state. That is why these are called typical transition elements. Next, last point regarding this one, that is, take zinc. Zinc electronic configuration 4s2 3d10, argon 4s2 3d10. That means 1s2 2s2 2p6 3s2 3p6 3d10 4s2. That means in elemental state, this is an elemental state, zinc having incompletely filled in valence shell but not incompletely filled in penultimate shell. See, penultimate shell is completely filled, so that zinc is not a transition element. Zinc is not a transition element. Zinc exhibit one oxygen state only, that is plus 2. Plus 2 means we have to remove 2 electrons. That is removed from, that will remove from outer shell. That means from 4s. Then its configuration becomes for Zn plus 2 4sg argon 4s0 3d10 argon 4s0 3d10. This is the electronic configuration for Zn plus 2. In that configuration also zinc not acting as transition element, because 3d is completely filled in oxygen state also. But in case of Cu plus 2, this is incompletely filled, that is why it acts as a transition element. But in case of zinc, it is not acting as a transition element in elemental state as well as in oxidation state. So what is the point here? This zinc, cadmium, mercury, all are not transition elements. These are only d block elements. This group is called 2 big group. So what is the point here? All d block elements are not transition elements, but all transition elements are d block elements. From this here to here, these are transitional as well as d block, but from here to here, these are d block but not transitional. So except this group in period and d block, all are transitional elements. So what is the statement? All transitional elements are d block elements, but all d block elements are not transitional elements. This is very important point. Next, one more point regarding this one, that is, if you observe electronic configuration, it's the general electronic configuration ns122 n minus 1d 1 to 10. This is the general electronic configuration for d block elements. Next, if the elements exhibit this configuration ns2 np6 nd10, those are called pseudo inert gas configuration. If the elements exhibit this configuration, which configuration? ns2 np6 nd10, those are called pseudo inert gas configuration. For example, Zn plus 2. What is the electronic configuration for Zn plus 2? 1s2 2s2 2p6 3s2 3p6 3d10, because 4s is 0. That means, see, this is ns2 np6 nd10. That is why this Zn plus 2 is considered as pseudo inert gas configuration. Similarly, there are some more elements. Cu plus, this configuration is 1s2 2s2 2p6 3s2 3p6 4 3d10. Actual copper configuration is 4s1 3d10. Plus 1 means we have to remove that last electron. Then 3s2 3p6 3d10. This is also base ns2 np6 and d10. Nothing but this is also pseudo inert gas configuration. Zn plus 2 Cu plus, these are having pseudo inert gas configuration. So what is the pseudo inert gas configuration? If any elements possess this configuration ns2 np6 and d10, those are called pseudo inert gas configuration. So this is all about introduction of d block elements. Thank you.